Hello viewers, this is Nasir Hussain from Bentley Systems Bridge and Tunnel team. I will introduce OpenTunnel Designer to you in this video. Let's have a look into the current market. In the current market, there is no comprehensive integrated software solutions specific to tunnel project. Thus, designers and engineers need to handle multiple different applications. This results into regeneration of data and eventually inefficiencies due to lack of cohesion. Therefore, to eliminate the current discrete nature of design activities and to increase productivity and efficiency, Bentley introduced the unique tunnel solution, OpenTunnel Designer, where it is streamlined in a single workflow with leapfrog works and Plaxis for geotechnical analysis and design input and output. OpenTunnel Designer is a unique and true 3D solution that creates intelligent and parametric model of tunnel and excavation, performs clash detection, develops geotechnical analytical model, generates reports and plans. We know design-based projects require a lot of collaboration. We get information from multiple data sources from many different disciplines and we get in many different file format as well, like DGN, DWG, RBT, etc. And sometimes we struggle which one is the latest information. Thus, we introduced the Connect Edition connected data environment that spans the desktops, servers, and cloud services that spans the life cycle of design through operations, enabling hybrid workflows that are automated from the office to the job site to the field. And that platform is MicroStation. MicroStation that we know as a drafting software, but that evolved to become a digital platform for all Bentley products. Open Bridge, Open Roads, Open Rail, Open Tunnel write all their information into a single file format, the DGN file, a format that is common for all applications, that use of a federated model with live references in which the information stored in the DGN file is accessible to all open apps, but most importantly, no versioning issues for future upgrades. OpenTunnel Designer enables users to create 3D physical modeling of tunnel, reinforcing and excavation, from where geotechnical analytical model is directly extracted into Plaxis without any need of scripting. Reinforcement of individual object is modeled in pro-structures in fine details. Detailing and plans are produced using pro-structures, OpenTunnel Designer, or even using MicroStation detailing tool. From the 3D model, quantities and geometry reports are also extracted. From the physical model in OpenTunnel Designer, 4D model consisting of construction sequence, schedule and simulation is created in Synchro. OpenTunnel Designer creates an intelligent digital twin of tunnel, allowing users to easily integrate project data across disciplines, teams and locations into a single model. The outcome is a fully automated digital twin model that extends past the design and construction phases to allow users to evaluate real-time design, construction or operational changes throughout the life cycle. In more detail, borehole data feed through Leapfrog into OpenTunnel Designer. OpenTunnel Designer then models soil strata and the tunnel with the survey and alignment directly imported or referenced. Plaxis can then perform geotechnical analysis and design by extracting the model from OpenTunnel Designer. Project deliverables are directly extracted from OpenTunnel Designer. Now we can look into the tunnel modeling in OpenTunnel Designer. OpenTunnel Designer can model conventional tunnel boring machine type tunnels. It has user-defined parametric tunnel sections. It has the extensive catalogs for sections, portals, shafts, rooms. It has direct connectivity with the open roads and open rail geometry. It can export geometry from land XML and use soil strata information from external applications. This is the OpenTunnel Designer interface, the menu bar here, toolbar here. We start from the left and go towards right. First, we import soil. Here, we are importing an IFC file, and once this IFC file is imported, we during the import, we define the boundaries which we want to import. And once this is imported, we are ready to create alignment or import an alignment. Here is an XML file, but also these are the other format we can import. And once this is imported, we can import the specific alignment here, which we want. We can also reference if we get an alignment from open roads. And now we are defining the tunnel type. Like here, we will define the conventional tunnel type. And now we are assigning the alignment for this conventional tunnel type. Once this is ready, we are assigning some reference lines. Here, we are providing 4 reference lines. We have given the start, and then we'll select the direction of the tunnel, and then we'll select the end. Once we are done, this window comes up where we got another opportunity to modify the stations or also the skew angle or also the length or the reference line notations. We can change from here. And once this is done, the next step is to create template to do the model in this window here. So to place tunnel, we come into the template and we go into the tunnel. But here we don't see any template. That means we need to import it from our catalog. There are already default catalogs. From there we can import one catalog, and that has predefined variables. And also the linings are defined. Each lining has its own material type, and we can select the materials as well. Once this is done, the tunnel is ready to be modeled. And here we select the tunnel template, and in this window we have the section lengths and other data like offsets, and we select here from the start to end, and this models the tunnel. Once the tunnel is modeled, then the next stage is portal. Again, we need to go into template and we select our templates we want from the catalog. Here we have selected 2 templates and we have the variables. Again, those are the predefined variables. And in the portals, when it is ready, this is ready to model. And here we can see 2 templates we can assign. Actually, these 2 templates is for only one side, either entrance or exit. It means if you have a portal that has different dimension on external or internal and you want a linear change, OpenTunnel Designer has given you the ability to change that in a linear way. That's what we see here. But if we don't need a change, we can assign same template for the external face and the internal face. And in that case, we will see no difference in there. What currently we are looking at, we in this window, we are selecting same template for both of them, and then we are at the end of the tunnel where we are assigning the template. Here also another thing is we have template inclination for the external face. In this external face, we have defined 15 degree, and we can see that clearly the face is inclined. And this is we are looking at from outside, and this is also the dimensional variation we can clearly look here. Then we have the placing shaft. For placing shaft, we come into the template, and template directly comes from the catalog. And this template shaft is sort of pipe. It has the opening. So we define here the offsets, elevations, and the offsets from the reference line. And we just select the reference line, and then it will model. To see that clearly, we can go into our Explorer, and from there, from the drop down, we can check out the things that we want to display off. Now we can model the place rooms. Placing rooms is actually a placeholder, but we can go into the template and select the templates that we need for the placing room. Here also the horizontal offset, elevation, and references are there, and we selected the reference line, and the room is modeled. We will look into excavation subspaces and reinforcement modeling. For excavation subspaces and reinforcement modeling, we come into the template, excavation template that comes with the tunnel template. Also, the reinforcement template that comes with the tunnel template as well. And in this template, we can see here there are 5 different type of reinforcement, from shotcrete to rock bolts. Shotcrete, it has permanent walls and temporary walls. Jet grouting, it has crown and floor, front and trail. 4 poles, fiberglass and rock bolts are all around. Then these are ready here. So we need to come into construction, and we need to assign onto our model. So excavation subspaces, we just need to select the tunnel. It will be assigned onto our model here. Similarly, for shotcrete, permanent wall, and temporary wall, we just select our tunnel here, and then this is the assignment process. From the Explorer, we can display off and display on items that we want to put off or on for the time being. And then we have 4 poles, fiberglass, and rock bolts that we can model as well just by clicking on the tunnel. So if we need to put off something, we can do from the Explorer. That's what we just did. And now 4 poles. We are putting a driving angle changing from 0 degree to 10 degree. Also the rock bolts, we can model it here. The temporary walls, shotcrete walls, that we have modeled here, and subspace excavation, we just put the display off. Now we can put on, display on all items that we have modeled, and now we can display off the excavations and the temporary walls to see the complete tunnels. Now we'll look into the auxiliaries modeling. In auxiliaries modeling, we can model any elements that needs to be extruded or can be modeled at any intermediate spacing. So we need to come into the auxiliaries to model the item. Before that, we need to come into utilities, and in the catalog, in the auxiliaries, we need to set up. If we come into a tunnel template here, let's say this one, the TBM T1, here we need two elevated walkway and roadway in the middle or a rail corridor. Then we come into the define. We draw closed shape. We have three closed shaped drawn here, and those two at both sides are the elevated walkway. And once these are done, we tag those elements. So once this is done, we should save and define the materials from here. Now we come into the template. We can see our template for auxiliaries is ready. Now we come into the auxiliaries placed by extrusion. We just select the items that we want to be modeled here, and you can see the walkways are modeled. Also, we have taken the rail track as a reference here. Now we'll look into catalog from where the templates are extracted and then modeled. We import templates from catalog. Templates are in the utilities, which is the central depository of all templates. If we go into the tunnel template, we can see here all the templates. So we can edit, we can create a new one. So if we go into any one here and then we can go inside, we can see there are three different color lines. So it's three different closed lines needs to be drawn and then needs to be tagged. So the top one we can see that is tagged as theoretical excavation. Then we have a shortcrete. So this is the lining extra doors, and then we think this is a concrete panel we're going to do. So this one is the lining intradoors. And all these things also here is intelligent programming is here. We can define the constraints as we need. So this panel here is the user-friendly graphical programming that we can impose on these sections as we need. And we come back to into our template. So once we are here, so if we change a value, which is, we can see the thickness has been changed. Also we can change it to, so we have changed it. So, and then also we have the lining definition that all individual parts and individual parts materials are also selected. We can select. For ring, we said, all right, we need 50 to 60 MPa, or we have the similar thing for the portal. We can see it is one closed line and that needs to be tagged as portal extra doors. And this has the similar programming capabilities here. If we come into excavation subspaces, we define through here. We have the soil here. So we define this way, like we want to excavate this soil first and then the other part and then this part. So we have defined three different part of soil and then we tagged it as excavation subspaces. Once this is done, and we just need to select the materials from the drop down, and we also need to select the whether we want it to transfer into plexis. So we just check them. Then we have the reinforcement here. In the reinforcement, we can see there are 5 different type of reinforcement. First one is the shortcrete. Again, we have drawn inside by going into the define. So we defined it. Okay, this one is a permanent shortcut we need. Also this one we defined as a shortcut here. As a physical modeling, we will we have defined here as a permanent shortcut. This one is the temporary walls. So we have defined two temporary walls. One is this one and one is this one. Once these are excavated, then we would demolish this temporary wall. So those are tagged through this icon. Then this is we modeled as shortcut here. We want to inject grout here to stabilize the soil. So we want this one as a jet grouting, and that we want need to take it into the plexus. So what we do, we just define here this one as jet grouting, and we define that okay, we want to send this to plexus as a jet grouting. But here we did because we want to see that in our physical modeling this part to calculate the volume of the jet grouting. Four poles we can define, we can give the diameters and offsets and length here, but also we can go into define custom. Here we have drawn and I defined as a circle here. We can also define the fiberglass here, and then we have the rock bolts. So again, the rock bolts are defined through here. So we have drawn the lines from the intradoors as we need. We might need in different places as well. And then we have tagged as a rock bolts, and these rock bolts, if we also want to send to plexus, we can check it. So this template is now ready to go along with the tunnel template. Also, we have the shaft, so we can go into there and provide the dimensions, diameter, thickness, and length, and we can add multiples. Also, we can add the slab as well here. And rooms is a placeholder. It has the height, length, and width that we provide here. Once these are set up, these are ready to be modeled using the construction. Now we'll look into tunnel modeling for TBM types. For TBM types, we have the parametric sections in the catalog. We have the segments, thickness, width, lining systems, automated angle segmentation, front and rear unfolded ring views as well. For a TBM type tunnel, we need to create our catalog through the utilities catalogs tunnel. We can create here. TBM is essentially circular, so we need to draw circles. Once we have drawn our circle, so let's say this is our theoretical excavation, and then we have concrete shortcut, and then we have concrete panel. So this is theoretical excavation, which will tag through this. Then this is lining extra doors, and then this is lining intra doors. We have just tagged. And then also we can put the dimensions here. We can put as new variables. For all three circles, we can say they are concentric. We can go into the variables here. We can rename if we like. Once all this done, we can save. Then we need to come into the lining. We go into here, and here we can see we can define the number of segments. So let's say I have 5 segments or 6 segments. We can give segment thickness, and the annular gap is already given, like we have given 300 millimeter and 500 millimeter, so we can't change it. Ring width, we need to provide some width. It could be 1 meter, 2 meter, 5 meter, whatever. And then here is the 6 sections that we have. One of the section will be key, so we just need to define which one. So let's say I define this one my key section. And then also the other thing is, this is I'm looking at one circle, and once I give this value, I can see we are looking at from front and also from rear, and those are the just angle showing, like the front angle is at 0, and then 60, 120, and then at the end is 300. So that's the same way as the rear angles are given. Also we can see here lining system type, rectangular, rhomboidal or trapezoidal. We'll be able to quickly see. Before we go into that, here is the view mode. We are looking from front or rear, but we can also go into unfolded mode because we have given some value. Now we can see that. So we can see the panels, and then rectangular is the rectangular form of each panel. Now it could be rhomboidal, and also it could be trapezoidal, and when it is trapezoidal you can give a different angle of the trapezoidal as well, like whatever angle you like I changed it to 10 degree. And if this is the case, and then if I just put at this moment like rectangular, for example, so this is one strip and one circle. Now if I want the next one, next ring, another next ring, but we don't want on the same line, let's add the next ring. You can see the first ring is started at 0. Let's say second ring I want to start at 20 degree. Then I can add the third ring, 2/3, so 40 degree. So we can see 3 subsequent ring I have provided. Also we can change the rhomboidal and trapezoidal. You also have the material here, so you choose the material as you need, then you save and close. Now we'll look into the reports and plans production. We can generate input reports and quantity reports from the OpenTunnel Designer in the analysis and reporting. Once model is done, we can create reports by going into analysis and reporting. First we have the input report. We can select all units or the active units only, and then here we can select individual options or all options together, and then we just need to submit. It does create all the informations that we have input graphically, and also we can export these to different formats as we need, and we have the email option from here as well. Similarly, we can create quantity reports, and we can select the units and then we submit. So here we can see all quantities and the cost. If we have provided the price, all will come up here. We can get plan and profile view in longitudinal direction by using the place name boundaries. So if we come here, we need to select a sheet file. We select the scale. We'll not create a drawing here, so we just select the path. Let's say this is the plan view we want, then we accept. To get the profile view, then we'll open a profile view. We need to come into the place name boundary again, and then We come here. We input some values here. Here we'll activate the drawings and then we'll click here. Once this is done, here we'll select the scales. So this is the plan view and this is the profile here. We can see all the list here. As we have selected sheet index, inside the sheet index, we can see all our drawing lists. We can create cross sections by going into MicroStation detailing toolbar, where we can go into the cross section call out and we selected drawing sheet file from the drop down. And now we have drawn the cross sections where we want the section, and then we are selecting a depth. And this window comes where we select the scale, and this is 1:100 scale. So in the detailing scale is 1:100, and then this cross section is created for the tunnel. From OpenTunnel Designer, the physical model is transferred into ProStructures for rebar and steel detailing, schedules, and bill of material. In this tunnel model, reinforcement is modeled using ProStructures. Then the detailed 2D drawings and reports are extracted from the model with the bar schedule for fabrication details, where it provides high level of efficiency by allowing users not to create a fabrication model from scratch. Similarly, for this model, the structural steel elements like the ribs are modeled in ProStructures. Then the steel detailing as shop drawings, including necessary connection details, are generated from the model, saving a significant amount of time for the engineers and designers. From the model, quantities are also extracted precisely. Now we can look into the introduction about geotechnical analysis. Analytical model is generated from OpenTunnel Designer directly for Plaxis 2D and 3D. OpenTunnel Designer transfers soil layers, excavation, tunnel reinforcement, and lining. Firstly, an IFC model is imported in the OpenTunnel Designer. User can choose the boundaries for the import process. Soil properties, then we define inside the OpenTunnel Designer. In the excavation subspaces, the relevant items are to be checked to send to Plaxis. In the reinforcement catalog, items are also to be checked to be transferred to Plaxis. For example, jet grouting we want to send to Plaxis. So we check the item. Once these are done and the tunnel is modeled, we come into the analysis and reporting. Into the analytical cross section, we define our cross sections. And on those cross sections, we transfer to Plaxis as a plate or region. And then in Plaxis, we run Python script. And this Python script run by itself without any need for us to write any script here in Plaxis. Here, in a quick way, some capabilities of OpenTunnel Designers are shown. We can see the twin tunnels are modeled in fine details. The tunnels are modeled with roadways and walkways. We can also see the rock bolts are modeled all along for both tunnels. We can see the plan and profile are created using automated tool. TBM tunnel with rail tracks is modeled here. This is a cross sections that is generated using automated tools. Text favorites are used to have automated section information, cross-sectional volume, and defined text annotations. The cross-section then presented on a drawing sheet. Quantity and geometry reports are generated from automated tools.